Hi, thank you for attending. My name is Gabriel Reyes. I'm a sales engineer over here at Ingenious Technologies, and we're going to go over this webinar on RSSI. Okay, so first we're going to talk about some partner benefits. This all came to you as a partner, so you should already know some of the benefits. We'll go over some of them. You have the presentation RSSI. Using RSSI on our Easy Wi-Fi planner, so some tips and tricks on that, or what the difference between a capacity and coverage plan will look like. Also some other stuff as well, and then some questions and answers. Okay, for our partner benefit program, you have certain items there, such as training, special pricing, and from that partner program portal. And so basically, and also webinars is the one you're hearing right now. Okay, so let's go into RSSI. All right, so RSSI, depending upon which wireless engineer you're talking to, could stand for Received Signal Strength Indicator, Relative Signal Strength Indicator, or Radio Strength Indicator, plus other things as well. I like to say basically it's equivalent to the bars. So how many bars you have would be heavily derived on RSSI. So one thing to note about RSSI is that the only thing that's standardized in it, according to the IEEE standard, is the scale, which is min and max. So there has to be a minimum and there has to be a maximum, but in between the values of the scale, that's left up to vendor interpretation, which later on in the presentation, we'll let you know why that is a bad thing. Okay, how do you read the RSSI is based upon the scale of negative numbers. So closer to 0 is stronger and further away from 0 is weaker. For example, negative 30 RSSI is a much stronger signal than negative 80 RSSI. So benefits of RSSI is basically it's a quick summary of qualitative signal strength from the wireless client's perspective. So because wireless is half duplex, RSSI is only going to show you one direction. So if I was on an access point side and I'm looking at RSSIs, I'm looking at the access point's perspective of the client's to it. If I was at the client side, that's going to be the perspective of the client from the access point signal strength. The reason why this is important as a qualitative signal strength, because it's not an absolute, is that it saves signal processing cycles. Later on, we'll tell you why that's important. So there's no need for a spectrum analysis on the RSSI, which greatly saves your time. So if you're using the RSSI for dynamic rate shifting or for roaming, if you were to add the latency of an RF spectrum analysis, that would negatively impact those features and functions. So without having them in the RSSI actually greatly improves it. You're able to deploy this on lower end chipsets because you don't have a high-end calibrated RF chipset in there. Then you're able to put it on lower end chipsets for this relatively quick measurement of, hey, what is the RF signal strength looking like to me? The downside of RSSI is that it's not standardized across the vendors. So 3 bars on my iPhone may be completely different than 2 bars on my Windows machine, or even 5 bars on a Windows machine. Those could be equivalent signal strengths to the devices, but the perspective of those clients is different based upon the scale not being standardized. Another drawback is that it's only being done on the preamble of the 802.11 frame, which means that if it's not frame 802.11, I'm not going to see it. So anything like garage door openers, baby monitors, cordless phones, that's not going to be included in the RSSI measurement. As you can see here, the preamble is a small sliver of the entire 802.11 frame of the beacon frame. So if I'm just taking a small sample of a small section, I'm not going to get the full length of how it's going to impact the entire frame. Once again, it's not an RF spectrum analyzer, which also means that I'm not going to get the true signal to noise ratio. It's only done at the lowest data rate as well. So in the example we showed you on the preamble of the frame, that's only on the beacons. And in the wireless, it goes inversely, so for data rates for output power. So if the output power is very high, I'm going to have a very low data rate. If the output power is low, I'm going to have a higher data rate. The reason for this is because they're assuming that the reason why you have a high data rate is because you're closer to the access point. There's no need to talk very loud. If you're further from the access point, you're going to have a lower data rate, and there's a reason for you to talk louder to communicate to the access point. So the RSSI is not going to show you what the actual data frame is going to be. It's just going to show you what the beacons are. And if your traffic is not a lot of low data rate type of traffic, it's like multicast or unique or broadcast traffic, then that's not really going to be a good gauge of how well the signal is going to be at higher data rates. Values also change within the same model. Because Wi-Fi is not a highly calibrated chipset, basically you get fluctuations or differences between the same particular vendor, even on the same die, because they're all produced on one die. For example, if I had an iPhone, like an iPhone 4, another iPhone 4, the RSSI may be different on the same geographic area from the same access point due to the variations of that. That's why we always recommend that you take the lowest performing client that you have or you're going to be deploying in your network, and the lowest performing of those clients. For example, if I had a laptop and a phone, I would obviously choose the phone over the laptop because it's, antennas space is smaller surface area. And then of those subset of the phones, I'll take the worst performing phone. Obviously not something that's due to physical damage, but due to nominal lowest RF performance. And I would use that so you actually plan for the worst case scenario. Okay, so now we're going to go into the Wi-Fi planner and use an RSSI for Wi-Fi planners. So first we'll show you a coverage-based design. So in this particular design, you see there's, I think, 7 access points. And so basically in this design, they were only interested in signal strength. So a coverage-based design for contemporary Wi-Fi designs or deployment should be reserved for 2.4 only gigahertz band. It's not conducive for roaming or even moderate to heavy real-time network use, such as like Skyping or FaceTime, anything of that nature. And it should only be reserved for lightly utilized networks. I like to use it only for clients that do not support 5 gigahertz and actually only have that. You'd be surprised at how many devices actually have just a 2.4 gigahertz only chipset in them. Mostly I see it in medical devices where they just have the 2.4 gigahertz and not 5 gigahertz. So that varies differently from a capacity-based design. If you were to look at this design, it would have double the access points you would in the coverage-based design. Now, this particular design had a requirement for real-time application use. They had a medical cart going around, and they need to actually have a communication to a server so they could dole out prescriptions and doses and stuff of that nature. So they need to have communication all the time. So it was considered a real-time application. So that means they needed what we call a voice-strong network. This type of network is good because as the client roams through there, it can maintain higher data rates. A capacity-based design should be reserved for the 5 gigahertz band. It's conducive for roaming, and it's ideal for moderate to heavy real-time use, and for networks that are heavily utilized as well. So this is the type of network that you'll be designing in all your designs, or at least you should be designing. So some application use planning guidelines is basically if I were to talk to a customer and they would tell me, I would ask them, okay, what are you going to use the network for? And they say things such as Wi-Fi calling or Skype or video conferencing, or they want to be 100% wireless. I'm going to be looking towards a more voice-strong network, which means I use more APs, less output power. If they need voice over Wi-Fi calling, it's actually higher end access points with a better processor and more memory to handle those concurrent voice calls. And if it's if it's HTTP traffic or for email, I'm going to use less access points and just have a moderate output power for them because roaming is not really important for them in that regard. Check your roaming requirements, particularly for the clients as well. For example, a laptop would behave differently than a phone for roaming. I've seen laptops have, one, they're better clients, so they're able to hear better, and two, the roaming algorithms is mostly designed towards nomadic roaming, not towards seamless roaming, which means I only care about signal from point A and point B, not in between. Seamless roaming means I care about signal from point A, B, and in between as well. So it's also important to baseline your network to see if you have a pre-existing network, to see what the traffic flows look like. Since Wi-Fi designs are heavily driven upon application use, if I were to see, for example, a car dealership using a VPN type of application that's most important to them, then I would think of a voice strong network. So I would put more access points in there, lower power, because I know that that's the most important application there. If it's just like a standard email, not Office 365, but standard email, local client, then maybe I could design it for less access points with higher output power, because roaming is not really important in that particular requirement, because that application could survive, much longer latencies, much higher packet loss than anything such as Skype or FaceTime or even like a VPN, like the example we included with the car. So what we always recommend after the predictive modeling is do a site survey. It should always be conducted either ideally before and after, but if you can't do it before, like the building's not built yet, then maybe after. No matter which vendor of products you have for even predictive modeling, they recommend some site survey being done at the end. They help with the model accuracy for the number of access points and the placement of them, as well as they help get the proper information depending upon the type of site survey you do. There's a passive site survey and there's an active site survey, and they're used for different things. Most of the time you'll be doing a hybrid type of site survey deployment, which means that I'm going to be doing both. I'll be doing both because I want to know exactly what's going on in the environment. For a passive site survey, that's good for just checking beacons and checking attenuation values between floors or between objects. An active site survey would be ideal for actually determining what the cell size would be for a particular data rate. So if I was doing a voice strong network, I wanted to see what a data rate would be for the cell size for -60 or -70, I would actually use the particular type of climate and go out and determine that, and then mark it with some color tape, and then design access points appropriately towards that for the placement of it. Okay, so now we're heading to the questions section. Let me see how many questions we have. Okay. Now, we were having some trouble with audio in previous webinars. We're wondering, Thomas said we're not having any trouble with audio. And I do see we have, let me see. Okay, we're fine with audio, I believe. Yes, thank you. So one of the questions is, how do we have access to this PowerPoint presentation or this recording? It is available on our partner site. You could actually just email partners@ingeniustech.com, and we could get you the slide deck, copy of the slide deck, as well as this recording as well, or a link to the recording. Great question, thank you for that. Okay, we have another question here about auto power and band steering. So yes, every single vendor does have those features, but it's not part of the A211 standard. So every single vendor does it in a different way. So that means that it's all vendor proprietary. So if you're having trouble with your network, we highly recommend, it's not just us, other vendors recommend the same too, that you try to bring it more in compliance with a standards-based network and see if that improves your problems that you may be having. I believe on Android, you could go to the Google Play Store. That's a question from Thomas, thank you. You could try to find some options there. There is an option too for your iOS. I'm not quite sure if it's available for 12 or 13, because the last time they made a revision that I've seen was iOS 10 on that one. But there is also something you could do on iOS to actually show you the RSSI, not only of the Wi-Fi, but also of the cellular as well. So Android should probably have one as well. Haven't really researched it too greatly. What I normally do is when people have a design, I actually look at our management software, and I actually look to see what the RSI values of the clients are, and I sort it by that, and I determine whether or not they're having problems just based upon that. That will give you a load of information of, our clients roaming properly? Why is this client having a high RSSI when it's closer? Is this client having driver related issues? Is it an older client, like A211N client, which does not have the benefits of the newer amendments AC has for roaming, such as A211V and K? So I would look into those. Also, things I've seen before for roaming problems have been if people use mixed networks. So like, let's say we have our 2x2 access points that are N, and then our 2x2 that are AC. I've seen clients actually prefer the AC over the N because the client sees a higher 811 PHY rate, and they'll actually roam to the AC and oversaturate that one and leave the N access point, pretty underutilized. So that's also something to take into account. I like to use the same generation of at least Wi-Fi across the entire network so you don't run into that problem as well. But thank you, that's a great question. Okay, we also have a question about multicast traffic on the network. Yes, you are correct in that if you have a lot of multicast traffic or broadcast traffic on the network, it will be sent out on the wireless at the lowest data rates. And so if you have a lot of that traffic on your network, it is going to have an impact on your wireless performance. I would say that you could either filter that out or you could remove the lower data rates. So in 2.4 gigahertz, you can remove 1 megabit a second, 2, 5.5, and 11. That gets rid of all your B data rates. And so that forces the client at a higher basic data rate. In order to roam, now they may have some interoperability problems with some drivers of clients. That depends upon the clients. I've seen most. If you're going to have an environment that's going to have a lot of clients come in and out, you're going to notice that quicker, like in hotels. But like, let's say I go to hotels, I stay in them, I check the basic data rates of their access points. I see them at 12 or 24. So even other places are doing 12 or 24 as a standard. So I would say probably start there and work your way out. But that also does not mean the R signal just disappears when it's no longer that data rate. It still goes on, it still could cause interference. So that's the reason why if you're going to be removing the lower data rates, you actually reduce your output power and add more access points. But you don't want to create a situation in which it's roaming too much, because that's a problem, and you don't want to create a situation in which you're roaming too little, because that's a problem as well. And that's great. That's a great question. Okay, another question is, the RSSI is the signal strength between the APs, isn't it? Well, RSSI is actually, because Wi-Fi is, that's a great question. Wi-Fi is a half duplex medium. It's only a single direction. So, for example, if I were to check RSSI values on our access points, that gives me the idea of how well my access point could hear the client. That does not tell me how well the client could hear me. That just says how well I can hear the client. So if I was on the client side, I would get a full view of the entire link and determine whether or not there's an offset, because some clients are, they don't have good low noise amplifiers on the chipset like our access points. They have lower gain antennas. They don't have access to power as steady as their access points. So there's all these different factors that go into why our site would be different on one, like the upstream or downstream, because those are different directions. Okay, I think he meant to be, says, I mean the capacity to retain the device. If you're using things like band steering, then yes, that decision will be made on the access point side. And unfortunately, we like to say that we don't like to have those features on a network in general, because what could happen is this: the ultimate decider of the roaming is the client. So if you do a decision that the client doesn't like, the client may have behaviors which are not desirable as well. For example, if I just have a hard cutoff and the client doesn't know about it, the client doesn't have discovery time, and it could just be hopelessly trying to connect back to the access point. It could just time out into a continuous process of trying to connect and just not go anywhere. Or it could do that as well as doing the discovery process and trying to find someone to connect to. And by that time it connects to someone, the flow of traffic going through there is stopped and it causes a breakage. So there's a question here from Kevin. It says, what's the optimum RSSI value of a point-to-point ingenious link? We do have a document on this on our website. In fact, if you even Google RSSI, we actually end up, I think, on the first page of the fourth link down or second link down. We're pretty highly rated there. Basically, our point-to-point links should be between -48 and depending upon what the data rate should be, -70. Like if it's a closer link, it could be that way. But understand if it's a closer link, you're getting such low RSSIs, that has to be investigated of why that is. I've seen people do a 300-foot point-to-point link down a driveway, and they're getting like -83 RSSI. On both sides, it's because they had a lot of trees in the way. And their option was to either go above the trees or to trim the trees. and so they decided to trim the trees, which improved that RSSI a lot. Okay, so thank you for that question. Martin asks, can you speak to mesh applications? Yes, mesh. Mesh is basically this. A lot of people get mesh confused because it's been in the marketplace for a while. I would say this is the third time mesh has shown its head in the wireless space. Not many people know that because they weren't around or weren't actually in the wireless field when it first came out back in around 1998, I think. And it's good for home use and for small deployments, but if you're going to any larger deployments, there is some trouble with that because you cannot control the way traffic flows through your network. Basically, you're taking a layer 3 routing protocol, putting it at layer 2, and you're having a wireless link instead of a hardwire link. That's all mesh does is having a wireless link to an access point, and it has some link resiliency. You're not really adding any performance when you do that. You're actually taking away performance when you do that. So meshes should only be reserved for traffic on the other end of that link that's not going to be heavily utilized, or I can't run a cable and I know there's going to be lightly utilization over there. That's what we normally recommend it for. For RSSI, for mesh, it can use that plus other metrics as well to have a link cost and to change the link cost, just like what span and tree does or any other routing protocol. Well, span and tree's layer 2, but OSPF. So that's how that goes into play. Most of the mesh stuff is vendor proprietary. They want to keep it that way so that they make some profit on there. Because if you look, mesh was actually ratified in 2005 because 802.11s was the vendor interoperability for mesh. But many vendors did not decide to implement it because they didn't want their products to work with other products. So they wanted to keep their profit margins on that. So even mesh nowadays is still proprietary, vendor proprietary. But thank you for that question. Hopefully I answered it on mesh with RSSI. If not, just let me know and I could expand more on that. We have another question from Thomas that says, in the EAP 1300, there is an RSI option. Please go over it. Okay, so there's two options within our products. There is a band balance and band steering with RSI threshold, as well as a RSI threshold just to kick the client off. Those are the two options we have. So the first one is basically if a client hits a certain threshold for either 2.4 or 5, then they're going to try to influence them to go to the other band. Mostly it's 5 gigahertz. Then there's a band balance in which they try to balance the number of clients on there. They don't really go by RSSI because of the client count, but if the client is closer, has a higher RSSI, obviously you want those on the 5 gigahertz, not 2.4. That's how that logic goes. And then for the RSI thresholds, basically it just sends a deauth and has the client disassociate with the access point if it hits a certain threshold. And those are ideal if you, let's say I deploy the access point in a mall type of scenario, and the access point is close to the outside. I want to be able to kick people off that access point so they're forced to move to access points further inside of the store, or if they're walking out of the store, to not continue to hang on for lower data rates and negatively impact the wireless performance for other people that are in there. And if I'm using them for tracking them for any marketing data, I don't care if they leave my store. So that's where I would see RSI thresholds being used. But understand, when you're using them, it's a hard stop, and you may have some interoperability problems with clients. Now, if they're roaming out of your store, you really don't care about it. But if they're roaming further in your store, that's something to also take into account. So obviously, client behavior will be something or quality of experience was something you want to observe in that particular scenario and dial it in appropriately. You get the same results with directional antennas as well if they're highly directional. Okay, so I'm sorry about that by the time. So we are running close to the end. So if you have any other questions, you can always email it to partners and I'll be happy to answer them. Hopefully I went over all the questions you guys have, and you have yourself a great day.